So jumping back in, remember that the first step is always factor, so undistribute. So in this problem right here, I notice I could take a 2 out, so I'm going to take a 2 out. I'll be left with x minus 4. I notice that this is a difference of squares, so the square root of x squared is 16/4, so x plus 4 and x minus 4. And even though I can cancel these out, I'm going to wait. I'm not going to do that yet because I have to factor and then state my restrictions before I can start canceling things. Right here, I need a sum to 5 and a product of 4. So set up your x if you need to. Sum of 5, product of 4. So my numbers are going to be 4 and 1. So that would be x plus 4 times x plus 1. And then right here, sum to 8, product of 16. So what are two numbers that would add to give you 8 but multiply to give you 16? And the answer is 4 and 4. So x plus 4 times x plus 4. So I can set up my x. I can factor the long way if I need to. I can also just clean that up and rewrite it in factored form. Or I can just leave it as it is and state the restrictions before canceling. So really up to you how you want to do it. So taking a look at this, I'm multiplying, so I don't need to worry about this because that's only if dividing. So looking at my denominators, based on all of these, x can't be negative 4, and based on that, x can't be positive 4, which I can just write like this. Oh, erase too much. X can't equal positive or negative 4. And now I'm going to start canceling. So an x minus 4 cancels with an x minus 4. And an x plus 4 cancels with an x plus 4. So in my numerator, I'm left with 2 times x plus 1. All over x plus 4 times x plus 4, which is just x plus 4 squared. Now remember, I can redistribute. I can just multiply that all out, and I'm going to get this. But that's extra work that I don't need to do. I can just leave my answer just like that. So remember, factor, restrictions, cancel. So this one dividing, before that, see what you can factor out. So if I can take a 7 out, I'm left with x plus 2. If I take a 7 out, 7 goes into 7 and 28. If I take a 7 out, I'm left with x squared minus 4, which is a difference of squares, so I can keep going. Down here, 5 and 5, if I take a 5 out, I'm left with the difference of squares, so I can keep going. So I'm going to rewrite this one. So I have 7 times x plus 2 over x minus 1 divided by 7 times x plus 2 times x minus 2. Those difference of squares are really popular ones because people will stop too soon, but if you can keep going, keep going. All over 5 times x plus 1, x minus 1. Because remember that 1 is a perfect square. Okay, state my restrictions, and remember that I'm going to flip this. If you're dividing, both the numerator and the denominator, you need to keep in mind when stating your restrictions. So x can't equal positive and negative 1 based on these parts. And then based on this part right there, x can't equal positive and negative 2. Because I'm about to flip that. So my first fraction stays the same. I'm going to change division to multiplication, and I'm going to flip it around. So I have 5 times x plus 1, x minus 1 in the numerator. And now my denominator is the 7x plus 2 times x minus 2. And I already took care of that restriction over here. Because when I'm dividing, I need to look at both the numerator and the denominator. And now I'm going to start canceling. So x minus 1, x minus 1, x plus 2 goes with x plus 2. 7 and 7 cancel. And I'm left with 5 times x plus 1 all over x minus 2. That's it. Remember, that's equivalent to 5x plus 5 over x minus 2, but I don't need to do that step. Okay, taking a look at this one, start by factoring. There's nothing to factor there. This right here would factor to x plus 6 times x minus 6. And that's not a difference of squares. That's a sum of squares, so I can't do anything with that. So that's it. So looking at my denominator, if I look at that part, x cannot equal positive and negative 6. If I set this part equal to 0, if x squared plus 16 equals 0, subtract 16, so I get negative 16, square root it, I end up with plus or minus 4i, because imaginary, but I'm not going to be plugging that in. So that one, I don't have any restrictions. But remember, because I'm dividing, I need to look at the denominator and the numerator. And based on the numerator, x can also not equal 0, because 0 squared is 0, and I can't have that. So now I'm going to keep, change, flip. So I have x squared over x plus 6 times x minus 6 times, and I'm flipping, so I have x squared plus 16 over x squared. And the x squareds are going to cancel out, and that's it. So your answer is just going to be x squared plus 16 all over x plus 6 times x minus 6. Now let's say you had something where you had like x to the 7th and then x to the 5th, like that. Well, x to the 7th and x to the 5th reduces because 5 goes into 7. So that would come out to 1, and that would come out to be x squared. Because if I have 7 x's over 5, cancels out, left with 2. And it goes the opposite way as well. So like, let's say I have, I end up with something like ab to the 4th over a cubed b. Well, based on that, I'm going to have 2 left over in the denominator, and based on that, I would have 3 left over in the numerator. So be careful if your exponents aren't the same, stuff still cancels out. That goes back to a couple units ago. Taking a look at the next one, factor it first. So based on this, sum to 2 product of 1, well, that'd be 1 and 1. So x plus 1 times x plus 1. Okay, sum to 3, product is negative 10. So sum to 3, product is negative 10. That would be 5 and negative 2. So x plus 5 times x minus 2. And then this is the difference of squares, so x plus 1 times x minus 1. And because I'm dividing, I need to look at both the numerator and the denominator when I state my restrictions. So x can't equal, based on that, x cannot equal positive and negative 1 or negative 5 or positive 2. Those are my restrictions. Remember, you set each piece equal to 0 and you solve. So those are my restrictions. But now I need to keep, change, flip to see what actually is going to cancel out. So doing that, I have 2 minus x over x plus 1 times x plus 1, or x plus 1 squared, times, not x plus 1 times x plus 1 squared, but this, or like that. My bad. And then the second one, I'm going to have x plus 1 times x minus 1 in the numerator. And then the denominator, x plus 5 times x minus 2. So cancels, x plus 1, x plus 1, and then that's it. But if you notice here, there's something about this piece right here and this piece right here. And maybe you caught it, maybe not, but they're actually opposites. So if I'm looking at that, I have 2 minus x, I have x minus 2. Opposites like that, so not necessarily conjugates, but opposites like that cancel out to be negative 1. That's only if it's minus and it's flipped. X plus 2 over 2 plus x, well, 2 plus x is x plus 2. That would become a 1. But if I have x minus 2 over 2 minus x, that becomes a negative 1. And it works with anything as long as it's the same numbers backwards in a subtraction. So x minus 7 over 7 minus x, still negative 1. N minus 7 over 7 minus n still cancels to negative 1. So in that case, 2 minus x over x minus 2 would cancel to negative 1. So what I'm left with in the numerator is negative 1 times x minus 1 all over x plus 1 times x plus 5. Okay, now those don't work because one's negative, one's positive, so that doesn't cancel out. It's the x minus y, y minus x. And if you wanted to rewrite this and say, well, that's the same thing as negative x minus 1, or that's negative x plus 1, that works. So you could rewrite it that way. So don't forget, difference of squares, watch out for difference of squares, but also watch out if you have a minus b over b minus a, that's going to simplify to negative 1. Remember, x minus y, y minus x, n minus 7, 7 minus n, if I can even write. Any of those would cancel out to negative 1, but only with subtraction. And that's simplifying factor restrictions